Hey guys, just finalizing the setup everyone. How are you all guys? Am I audible? Am I visible to all of you? Hi everyone. Good evening Emlada, good evening Shubham, good evening Astha. Shinchan is here, very nice. Okay, who all are here guys? Hello, if you are able to see me, if you are able to hear me, just make some sound in the chat box guys. Very nice. Iron Man, hello. Ask your Avengers to assemble. Very good. Who all are here? Iron Man, Anmol, Pratik, Gagan, Ritika, Janvi, Simran, Tanuja, Baluni, Pranati, Ankit, Sakshi, Gagan, Rajeshwari. Oh my god, very nice. Very nice, guys. Very nice. No. Nobody is late here. Very good, guys. Very good. I'll keep my cell phone here so that I can read your chats as well. Okay. So guys, how are you all? I hope things are going fine with all of you. Very good, Iron Man. Thank you for asking for everybody to assemble. Okay, Captain is on the way. Very good. So guys, I hope all of you are doing fine and make some noise. Tell your friends that class has started. If you have not, then just drop a message to them, maybe on WhatsApp or Snapchat or I don't know whichever platform that you use. Tell them that the class has started. Okay. So for those who are on the platform for the first time, looking at me for the first time, guys, this is me, your Suri sir. Okay. And I'm an alumnus of IIT Bombay, but more importantly, nowadays I'm known as Mugambo on this channel. Why? Because when you will crack this examination of JEE, Mugambo khush hoga. Okay. Also, for people who are new, let me tell you what is the schedule that we follow on this channel. So guys, every day at 7 p.m. like right now, we meet for theory discussion. Okay, and on some 3 days, those are Tuesday, Friday, and Saturday, we meet for MCQs discussion. Okay. And also, let me introduce you people to your teachers. This is Love Sir. He is your chemistry teacher. This is Arvind Sir. He teaches you all mathematics. And yes, this is me, your physics teacher. Okay. Awesome. Cool, guys. If you are new to the channel, then definitely subscribe to the channel right now. Press the bell icon so that whenever your Suri Sir, Love Sir, or Arvind Sir come live, you will be notified and you will never miss out on any of the lectures. Okay. Cool. Awesome, guys. So let's start our discussion for a new chapter which is known as work, energy, and power. After laws of motion, I will say second most fundamental and second most important chapter of physics. Whatever we are going to learn here, it's going to be very useful for the next 2 years. In fact, for people who are going to pursue engineering after that, the most important fundamentals are being learned right now on this channel. We have already completed laws of motion. Now what we are studying is work, and work is obviously a very important work, energy, and power. Work is a very important quantity that we are going to start our discussion with. Okay, cool, awesome, guys. So let's start our discussion about work. Work is something that I'm sure you guys have heard earlier about. Okay, we say that whenever on any object, if you apply a force, if on an object you apply a force and the body starts to move and covers some displacement s, then we say that, how do we define the work done, guys? In that case, we define the work done as the product of force and displacement. Yes or no, guys? Yes, it is useful for NEET as well, all the examinations. So this is the definition that you guys learned in I think 9th standard or 10th standard, whichever year you studied about work. This is where we got introduced to work as the product of force and displacement. Okay, now what will be changed here, if you have been a part of the lectures when we were studying vectors, you should know that not every time, if you look at it, this diagram, you can see that force and displacement have the angle between them as 0 degree. But not every time that's going to be the situation. Maybe the force may act at an angle theta with respect to displacement. Okay, so that is why the work done in any general case is understood as the dot product of force and displacement, as some of you are already mentioning as well here. So the work done is going to be the dot product of force and displacement, and that is F into S into cos of theta. Or you can also say, if vectors are given in the rectangular component form, it will be there x components multiplication, y component multiplication, and z component multiplication, which will give you the value of the work done. Yes or no, guys? You are aware about this, everyone? And you all know that SI unit of work is joules, and its dimensions are something that we have already studied, m1, L2, T minus 2. And as it is the result of dot product, so definitely it is a scalar quantity as well. Cool? Perfect. Yes, Anvesha. So units is joules, dimensions are m1, L2, T minus 2, and it's a scalar quantity as it is the result of dot product of force and displacement. Okay, guys. Now, what you are looking at this point of time, this formula, this is applicable. This is applicable only when the work is being done by a constant force. That means the force which is trying to apply a work, which is trying to do the work, which is trying to apply pressure on the body and making it move, that work which we are calculating as Fs cos theta is only possible for a constant force, and that's what we are now discussing first. After this, we'll move on to the discussion towards variable force work done as well. So the statement that we have written, the mathematical statement that we have written, that the work done is F into S into cos of theta, right? What I'm going to do now, I'm going to take the force which is inclined at an angle of theta, and I'm going to resolve it into two components. What you see here, that the body is getting displaced to the right hand side by an amount S, and the force has two components. Let's call the X component as Fx, and let's call the Y component as Fy. So now you can say that there are two forces which are acting on this body. One is perpendicular to the body and one is parallel in such a way that this is the direction in which the body is moving. So what I will try to do now, I will try to look at the two forces and the displacement here. So if you see that this is the direction of Fx and this is the direction of displacement, so the angle between both of them is 0 degree, right? Theta is 0 degree. But if I try to talk about the other force, which is Fy, and this is displacement, the angle between them is 90 degree. Such is the orientation that we have resolved the force into, right? So if I try to write down the work done due to X and Y component of the force, I will say that the work done by X component of the force, it is not the work component, okay? It's the work which is done by the X component of force. So that is basically Fx into S into, just a minute, guys. The magnitude of displacement is S only. So the value of force is Fx, displacement is, this is what I'm trying to do, finding the work done by this force, and the angle between them is 0 degree. What is this now? This is Fx into S only, right? This is what we get as the work done, right? And now if I try to write the work done due to Y, it comes out to be Fy into S into cos of 90 degree. And we know that cos 90 is nothing but 0, right, guys? So now if I try to write down the total work, we will say that work done being a scalar quantity, I will directly add it as Wx plus Wy, which is work done by X component of force and work done by Y component of force. So that comes out to be Fx into S plus 0, which is nothing because Fx, if you see here, Fx is nothing but F cos theta. So this is F cos theta into S, or simply F into S into cos theta, which you expected the work to be. Right or not, guys? Means what I'm trying to tell you all here, that whenever we are calculating the work which is done by a force which is inclined at some angle to the displacement, it is only the component of the force which is along the direction of displacement which will do the work. Okay, so on a body, if you have a force acting and this is the direction of displacement, then only the component which is F cos theta is going to do the work. F sin theta will not effectively be doing any work. Okay, it will actually be wasting the efforts of the force which you are applying. Okay, guys. Now, as I said, this is the story as long as you are talking about a force which is constant in terms of magnitude. What if the force acting on the body starts to change? If the force becomes a function of displacement, say it becomes the function of x, then what will happen here? If I put different values of x here, I will get different values of force. So in order to write the work done, which is F into say x into cos of theta, then the value of force itself will not be a constant. So I cannot directly write the work done as Fx cos theta. So what you are going to effectively do here, you are going to divide the entire journey in which the body is being taken, say from point A to B, when a force is acting on it, you are going to divide it into small displacement, each displacement being x. Okay, and you will say that in each such displacement the work done will also be very small dw. So you will find out the total work as the integration of all such dw's. And what exactly those dw's are going to be? They are going to be f into dx into cos of theta, or simply integral of f dot dx. That's how we are going to find out the work done when you will have your force being variable. Variable means what? As the body moves, the force acting on the body changes. As you see in the animation, whenever we are going to have a spring connected to a block, the force which will act on the block is going to be a variable force. Okay, so let's try to find out a situation where, say, you have a force which is applied on the spring, and that force that you are applying is equal to the spring force, and the force that you are applying is, say, F. So at any point of time, the magnitude of external force is equal to the spring force, and that is equal to kx. In fact, the magnitude is basically kx. And say the body is moving to the right side by an amount, say dx. I want the body to, say, go from x equal to x1 to x equal to x2. So my objective is to take the body from coordinate x1 to x2, and in that I'm going to take the body by small such displacements, and we have to find out the work which is done by the external force. So work done by external force, if you see that the body is being taken to the right hand side and the displacement is also to the right hand side, that means theta will be equal to 0 degree between force and displacement. So I will write that the work done is going to be integral of f into dx into cos of 0. What I'm doing, I'm writing this integration equation here. Okay, so what is the force? Force is kx, as it is a function of x, into dx into 1, and x is going from x1 to x2. So k is something which we call as spring constant. I forgot to mention that. So that spring constant is a constant, it comes out, and integration of x dx happens from x1 to x2, and that comes out to be k x square by 2, varying from x1 to x2. So the work which is done by your external agent in this case, or the force which is applied externally, comes out to be half k x2 square minus x1 square. Okay, now is the formula important? Do I need to remember it? I will tell you that later on when we are going to speak about energy. Okay, today's discussion is about work. When we will speak about potential energy, I will come back to this discussion. Okay. So guys, now based upon this understanding, I also have a very important point to raise here, and that is that because what you are finding work is basically an integration of f into dx into cos of theta, or simply integration of f dot dx, that simply means that the area bounded by the force and displacement graph, whatever is the area that you're going to find out here, guys, that area will represent work done by the force. Okay, you know that the physical meaning of integration is to find out the area bounded by the graph, and that is what will happen if you will draw a graph between force and displacement and find out the area with displacement axis. The area will represent the work done. Okay, cool, perfect, yes, awesome, Pranati, very nice. So guys, let's strengthen our understanding by solving a few questions here. Okay, let's solve questions based upon work done. What you will have to remember is, if it is a constant force, then this is how you are going to calculate the work done, by simply taking the dot product. If it is a variable force, you will have to do the integration. If a graph will be given, we will simply find out the area. These are the three things. For constant force, f into s into cos theta. For variable force, integral of f into dx into cos theta. And if it is a graph given, we'll find out the area bounded by the graph. Okay, cool. Okay, Iron Man and Anupam, let's go forward. So question says, we have a uniform force of 3 I cap plus j cap acting on a body of mass 2 kg. Hence the particle is displaced from this position, that is R1, to this position R2. So if I try to find out the work done, I will need to find out the value of displacement, which is final position minus initial position. Okay, which means what? 4 I cap minus 2 I cap plus 3 j cap minus 0 j cap, and last is minus k cap minus k cap. So what do I get displacement as? It is 2 I cap plus 3 j cap minus 2 k cap, and the force is given to us as 3 I cap plus j cap plus 0 k cap. That's the force given to us. So how will you find out the work done? As I said, it is multiplication of x components, multiplication of y components, and multiplication of z components. So that is 2 into 3, that is 6, 3 into 1, that is 3, and 0 into minus 2 will come out to be 0. So the answer comes out to be 9 joules. Got it, guys? Answer comes out to be option C, that is 9 joules. Very nice, guys, very nice. Keep it up, keep it up. Okay, let's go to this one. We have a body of mass 10 kg which is moving on a horizontal surface by applying a force of 10 Newton in the forward direction. And if the body moves with a constant velocity, very important point, it says that you are applying a force of 10 Newton and still the body is not accelerating, its acceleration is 0, its velocity is constant. That simply means it has a backward force which is acting on it, maybe that is friction, and that is also equal to 10 Newton. Okay, so if the body gets displaced by this constant velocity by 2 meters, then we have to find out the work done by the applied force. Means what? Work done by this force is what we have to calculate. So if you look at this, it is force into displacement into cos of angle between them, which is 0 degree. You see that this vector and this vector are along the same direction, that is force and displacement. So that's why the angle is 0 degree. Force is given to us as 10, displacement is 2, cos 0 is 1. So work done comes out to be plus 20 joules. Okay, guys, work done comes out to be plus 20 joules. Answer is option A, guys. Okay, very good. How about this one? In the previous problem, the work done by the force of friction. Tell me, guys, how much do you think is going to be the work done by the force of friction in this case? If you had the force of friction, which is also 20 Newton, body is displacing by, force was 10 Newton only, body is displacing by 2 meters. What do you think will be the work done in this case? Okay, very good. Theta is going to be 180 degree. So if I try to write the work done, it is friction into displacement into cos of 180 degree. Okay, that tells you what? That it is 10 into 2 into minus 1, that comes out to be minus 20 joules. So the work which is done by your external force and the work which is done by your friction force are giving you the net work done, the total work done. If I say that this work done was W1, and if I say that this work done by W2, so W1 plus W2 comes out to be 0. And that is why later on we'll learn that the body is having a velocity which is equal to constant. Its velocity and kinetic energy are, that is why, not changing. Okay, very good, very good. How about this, guys? Can you tell me what is the work done by the normal reaction force when the body is moving like this? What do you think is the answer for this one? What is the work which is done by the normal force here? N into S into cos of, perfect. It is angle which is 90 degree. So work is not being done by the normal force, and the answer comes out to be option C. Perfect. Very good. Very good. Good, yeah, good. Very good, guys. Okay, now we have a graphical question. You see that a graph is given. Question is asking us between x equal to 0 to x equal to 6, how much is the work which is done? So we have to find out the area bounded by the graph to calculate the work done. And work done is going to be half. This is basically a trapezium. Okay. So for trapezium, the area is half into sum of parallel sides. Parallel sides are 3 and 6. So 3 plus 6, and gap between them is also given to us as 3. So this is 9 into 3 divided by 2, or simply 27 by 2. So the work done comes out to be 13.5 joules. Okay, guys, that's what I was talking about. When you have a graph given to you, all you have to do is find out the area bounded by the graph between 0 to x, which is 6 centimeter here. Okay, very nice, guys, very nice. Keep it up, keep it up. Next question. This time also we have to do integration. We have a variable force given, and the body is moving from y equal to minus 1 to y equal to minus a to y equal to a. So work done is going to be integral of f into dy, assuming that the angle is 0 degree. So the force is given as a y square plus by plus c into dy, and it goes from minus a to plus a. So first part integration will come out to be y cubed by 3, second will be y square by 2, and third will be simply y from minus a to plus a. So let's put the limit. It is a by 3, a cubed, and minus minus plus a cubed. It's minus a, okay? Similarly, b by 2, when you put the limit, as it is a square minus a square only, because minus a square will still remain a square, and a minus sign will not convert as plus. And last one, c into a plus a is what we are getting here. Okay, so you see that this value becomes 0, and what we are getting here is 2a cubed by 3 plus 2 times ca is the work done, which is option B. Okay, very nice, very nice, very nice. Samartha, Satvik, Thanos got the answer. Very good. What about Iron Man? Thanos का आंसर तो आ गया, आयरन मैन का आंसर आया कि नहीं? Very nice, guys, very nice. Let's go to this one. Now this question has a 2 kg body moving in such a way that its position is changing like this. So what is the work done by the force in first 5 seconds? So if I look at t equal to 0, the body's location comes out to be 3 into 0 square plus 5, which is 5 meters. So this is x initial, and at t equal to 5 seconds, x final comes out to be 3 into 5 square plus 5, which is 75 plus 5, that is 80 meters. So the total displacement is x final minus x initial, which comes out to be 75 meters. Okay, and if we try to find out the force, force will be written as mass into acceleration. For that, I'll need to find out the acceleration here. So from here, guys, the velocity comes out to be dx by dt, which if you differentiate comes out to be 60, and if you find acceleration, which is dv by dt, comes out to be 6 meters per second square, and the force comes out to be 2 into 6, or simply 12 Newton is what I'm getting here. So my displacement of the body is 75. Okay, let's see, Anupam. And force is 12 Newton. So it is F into S, assuming angle is 0 degree, nothing has been mentioned. So we'll always assume the angle to be 0 degree here. So it is 12 into 75. That comes out to be 900 joules. And that is option C. Okay, that's a JEE question, by the way. Very good, guys, very good. Let's move on to this one. A very similar question. This time the equation is given like this, and displacement is to be found for the, as in work is to be found for the first 6 seconds. So if you rearrange, you will get x as t minus 3 square. So at t equal to 0, x will come out to be minus 3 square, which is 9 meters. And at t equal to 6 seconds, x will come out to be 6 minus 3 square, which is also 9 meters. So x initial and x final both are coming out to be 9 meters. That means displacement, which is x final minus x initial, is coming out to be 9 minus 9, which is 0, which tells you what? That the body has net displacement as 0. Therefore, the net work done will also come out to be 0. Okay, very good, very good, perfect, awesome, guys, awesome, very well done, keep it up. Let's take it a notch above and let's solve this question. We have to find out that if we have a block placed on a platform and the platform is going up with an acceleration of g by 2 upward, then we have to find out the work done by the normal reaction force here. We know that the normal reaction force is acting upward and the weight of the body is acting downward. So if I try to find out normal, I will have to write n minus mg equal to ma, and a is basically g by 2. So the normal force will come out to be 3 by 2 mg. If you will put the value of a as g by 2, so this will be mg by 2, this mg will come here, so normal comes out to be 3 mg by 2. Okay, guys, now we have already got the value of normal here. Normal force came out to be 3 by 2 mg. Let's try to find out the displacement, as the acceleration is constant and the body started from rest. So it will be ut plus half at square with initial velocity 0. I have g by 4 t square as the displacement. So the work done will be normal into displacement into cos of 0 degree. You can see that displacement and normal are on the same direction. So I have 3 by 2 mg into g by 4 t square. I get the answer as 3 by 8 mg square t square as the work done. Getting it, guys? Answer comes out to be option B. C for Corona? No. I would say it is B for Bhago Corona. Okay, B for Go Corona it is. Mugambo Khushua. Yes, very much. Thank you, Nazeen. What's your name? Thank you, Nazneen. Thank you so much. Yes, Bhargav, I remember you. Okay, guys, time for your homework question. You have a force given and the body is moving from a comma 0 along x direction, then a comma a. That means body goes from 0 comma 0 to a comma 0 first, and then it goes from a comma 0 to a comma a. So body actually goes from O to P to Q, and a force is acting on the body, which is given to us already. You have to find out what is the total work done if the force is given as minus k y I cap plus x j cap, where k is a positive constant. Okay. Thank you, Santara. So guys, solve the question, and definitely not in the chat box, but answer in the comment section of this video. Okay. Cool. Also, for people who are looking to join Vedantu's platform, where more than what we get on YouTube, we get to, discuss the doubts with all the master teachers. Also, you are able to appear for the online test which we conduct. So that is what is an additional advantage of coming on Vedantu's platform, guys. If you are interested, then definitely this is the link which you have to follow, and that link will, when you will click on this, which is available in the description, you will be directed to the Vedantu's homepage. Select the standard that you are in, say 11th standard you select the exam that you are preparing, and then you will be enrolled, and what you are going to get is live interactive classes, assignments and notes, and a lot of tests on JEE pattern along with the analysis of the examination. Let me just give you a brief of what you should expect out of Vedantu Pro. 40,000 plus hours of live teaching, a lot of teachers who are very well experienced to teach you, lot of tests and assignments, option to choose between English or Hindi lectures. Okay, continuous review and suggestions with respect to what is your area of improvement, what are the topics you should work on, and unlimited access to micro and crash courses. So guys, this is how actually Vedantu platform looks like. This is Pulkit Cert, where you are able to write your doubts and questions to ask the teachers. This is the platform where teacher is teaching. Okay, so this is how the platform looks like. Okay, so if you are interested, then there are multiple subscriptions possible, ranging from 1 month to 12 months or 1 year. So there is monthly, quarterly, half yearly, and annual subscriptions available for you. If you enroll now, then you will get an additional 15% discount as well. All you have to do is go on this link to enroll and use the coupon code, that is SMPRO. You will get additional 15% discount on any of the subscription that you will take. Okay. Also, if you guys are interested in joining our Telegram group, where we share the assignments, study material, and daily notes, then follow the link in the description, and this link will take you to our Telegram channel where you can interact with us as well. Okay, cool guys, I hope you guys enjoyed studying with me. Okay, if you did, then do press the like button, share this video with your friends, and subscribe to the channel if you have not. Along with that, press the bell icon so that whenever your Suri sir is coming live, you get the notification. Okay guys, so with the promise that you're learning, we will not let it stop. Even during these difficult times, we will meet every day, and we will continue our journey of JEE preparation for 2020, for 2021, and for 2022. So with that promise, I will take your leave, and I will see you very soon. Till then, keep studying, keep enjoying physics, and as I always say, stay safe. Bye-bye guys.